Chapter 5. There is no class on Friday for Easter break. There's my math labs, chapter 5 left. That's all that's left is chapter 5 from my math lab. But you can keep working on it. On As You Learn, if you go under dates and exams, your in-class portion of the final is April 29th from 2 to 4:30. And the take-home portion is due May 4th. I will take my math lab projects, any graded assignments up through May 4th, except for exams. Once I go over an exam online, when we start reviewing next week, I can't let you turn it in because we've already gone over it and you have all the answers. Or maybe if I do 4 problems and you do the other, I don't know, however many, 5, say, the 4 I did are not going to count. And so keep that in mind. If you do have an exam, you want to try and get it done this week, or the very beginning of next week. So I'll probably do exam 1 the first day, Monday. What else? So any questions on that? So our final is April 29th. Any late material needs turned in by May 4th. I will not take off except for those exams. Under attendance homework project, there was a project put up last week. You need the material from today to complete it, though. It's due Friday, but I will take it up to the May 4th. That's fine. Okay, gonna open. There it goes. Open. Jeez. Okay, there it is. So you want to think about 2 different cars. One is like your dream car, and the other one's what you can afford. But you want to pick 2 cars. It is up to you what websites you use. There's a couple here that you can use to compare with, but it doesn't matter to me which one. You want to find the MSRP, the blue book value for each car. And then you're going to find financing. Don't forget, you want to add the tax before you finance. And we'll show you how to find payments today using the calculator. Cost for gas. And then you're going to make one of these flyers for each car. So 2 flyers. The only thing is, it won't let me delete into this file. I should just make a new one, but don't include insurance. Most companies want too much information. I haven't found one that will just quote you prices. So unless you want to use your insurance company and find out what it would be, I don't want you to try and do it online because they don't need to have all that information and bother you. So the insurance part, monthly insurance costs, you do not have to have that. And then I'll write a paragraph about it. So you're only turning in the 2 flyers and the paragraph. Any questions on that? Have fun with it. It's just It's neat to see different cars, some things I've never seen before. Any questions? Okay. Today we're going to cover section 5.3. Monday we'll do, or Wednesday we'll do 5.4, and then Friday there's no class. Section 5.3 mostly is helping you find payments, or if you have payments, how much they'll be at the end, and things like that. Those are called annuities. It's when you have a sequence of equal payments. You'll also see in some of these problems, it'll say payment period. The payment period is the time between payments. It's the compounding. If it compounds monthly, then there's a month between each payment. So your payment period is the time between payments. It's just your compounding amount. And when you are making payments, your compounding and your payments per year will match. So before, if you remember, when we used the calculator, it was one lump sum, so payment was one, but then compounding could be any value. When you have payments, they will match. When they talk about the term of an annuity, a term is the time, the number of years. There's three different, well, there's two different annuities plus a sinking fund. There's an ordinary annuity. For an ordinary annuity, payments are at the end of each cycle. So if it's an ordinary annuity, payments are at the end. If it's annuity due, they're due at the beginning. So payments are at the beginning. A sinking fund is a fund set up to receive periodic payments. To repay bonds, stock, assets. There could be a lot of ones that are set up. The difference, though, between the sinking fund and the ordinary, because sinking funds payments are at the end. That right there at end. A sinking fund, the payments do not have to be the same amount every time. Everything we're going to deal with, they will be the same amount. when they are the same amount, it just turns into an ordinary annuity. So for the most part, what we'll be doing, there'll be an ordinary annuity. Okay. On page 373, let's try number 13. 13 says, find the amount of each payment to be made into a sinking fund to accumulate the given amount. Payments are made at the end of each period. So find the amount of each payment. We're looking for payments then. It said to accumulate the given amount. If you're accumulating, that's how much you want at the end. That's future value. And in this case, it was 11,000. 5% compounded semi-annually. Compounded semi-annually would be twice a year for 6 years. Now, remember, N is 6 times the number of payments per year. And payments are made at the end of each period. So if it's semi-annually, they're paid at the end of each period, which means there's 2 a year. Any questions on what these values stand for? So payment we hadn't used before. No, present value doesn't have anything in it, and we don't have a present value, so it's just 0. So we go apps, finance is already up there, enter, TVM solver, enter, and then here's where we put all our values. 6 times 2, 5, 0, 0. Now notice when you put that 2 here, it will change both of these to a 2. And then it said end. Whoops, I hit end. Now to solve it, we want to know the payments. So we go to payment and highlight it. And then hit alpha and enter. And there's your answer. Remember, one will be negative and one will be positive because one is money coming in, the other one's money going out. So the payments were $797.36. Any questions on that? Number 20. Says find the interest rate needed for the sinking fund to reach the required amount. So on a test, on ones that you can use the calculator, I would put these there so that you can put the answer so I know what you typed. Or if it's the take-home portion, make sure you use that so I know what you typed in the calculator. That way, if it was a careless mistake, I can see that and not take off as much. So for number 20, find the interest rate, okay? We know we're looking for interest rate. That's where we're going to put our cursor. Sinking fund to reach the required amount. Assume that the compounding period is the same as the payment period. We want compounded amount, which is future value. So 50,000 is the compounded amount to be accumulated 10 years times payments per year. Annual payments. Payments were 1,200. We don't have a present value. And they said our payments and our compounding would match, so this is 1. Any questions on that? Yes, and the last problem n was 12. Sorry, I didn't see that. Oh, you were. Okay. When I do ask questions, you will get extra credit for answering. Up to 4 points for the final. So we want to enter these. 10 times 1. And this is at the end because they said sinking funds, and sinking funds are at the end. So we're looking for our interest rate. I highlight it, alpha, and enter. And notice I got an error. Why did I get an error? What did I enter wrong? Okay, this would be 10. I got the 1,200 because they said quarter, whoops. Where did I get monthly? Oh, I looked at the one above. This is quarterly. I looked at the one above for some reason, so this should be 15. Sorry about that. So on number 20, oh, I completely did number 19. Sorry about that. Let's try number 20. Okay. This is a sinking fund, so this needs to be at the end. $100,000 is our future value to be accumulated in 15 years, quarterly payments. We're looking still for the interest rate. Our payments, the 1,200 is because of the payments, and that's the only thing I got right. So the 1,200 comes from the payments. 100,000 is the accumulated amount because they set it up here. 15 years. Okay, sorry about that. And then compounding, it said would be the same as your payments, so that would also be a 4. Any questions on that? Okay. What are we get? We'll round, I don't know, 2 decimal places. What are we getting for the percent? Anyone? Well, all right, I did want to show this. So the way I have it written, when we do this, we're getting an error. The reason we're getting an error, does anyone know what we should have done? Remember, when you have either present value, payment, or future value, if you have 2 of them in there, one needs to be positive and one needs to be negative. And so since I didn't make one of these negative, it gave me an error. Doesn't matter which one. Make sure also use the negative and not the minus. And that's why it was not giving us it. Now to get the answer, highlight the one you're looking for, and then you hit alpha and enter. So alpha, and then, because enter says solve in green, and then it will give you your answer. So the first time I didn't get an answer because I didn't have a negative. One of them has to be negative. So you should get 4.25%. Any questions on that? Positive. Trying to get I'm bringing up a list of everyone. I will give you 2 extra credit points today above anything else that you answer because of my careless mistakes. Let's try another. Oh, is there any questions on this one? I think the biggest thing was I took part from both problems. I wish I could like highlight on here, but it doesn't let me. Oh, it's letting me do it now. I must have done something wrong before. Okay, let's try number 29. No, it doesn't let me highlight. What the heck? Oh, that'll help me. Okay, so we're gonna do number 29. Let me write the numbers. So go ahead and read it. See where you would put the values. Because if I just do it, it seems really simple and it's like, oh yeah, I know that. And then you get home by yourself and you're like, oh, I don't know what I'm doing. It says find the future value of each annuity due. Annuity due, that's one we haven't done yet. Annuity due means it's due at the beginning. So let's see. Find the future value. Well, that's where you're going to put your cursor. Annuities due, that told us to mark beginning. We have payments of $1,000 for 9 years. Remember, N is 9 times your payments per year, which we didn't get to that yet. 8% compounded semi-annually. Semi-annually is how many times in a year? 2. And if we're making payments and compounding, they will end up in the same spot. So if you're making payments, these have to match, which means this is 9 times 2. Present value we didn't have, which is okay. We didn't need it because we have payments. And we're looking for this one. Any questions on that part? Okay. So we type it in. 9 times 2, 8%. 0, 2, 3, 2. And don't forget to highlight beginning. But once you do highlight beginning, don't forget on the next one, you're probably going to have to go back to end. Most of them are at the end. We're looking for future value, so we highlight that one. We hit alpha and enter. And it gives us, you get $26,671. Are there any questions on that? Okay. It's 29.35. Okay, number 35. Find the payment that should be used for an annuity due, so that means we're still at beginning, whose future value is given. Assume that the compounding period is the same as the payment period. So 35. When you find the answer, if you want to type it in, you can, and we'll see. Did anyone find it yet? Should be in the 200s. $265. Yes. So when we're doing that, I always read through and just fill in as I'm reading it. Other students like to just look for each thing in the problem. It's up to you. Find the payment. So I know I'm looking for payment. For an annuity due, that told me beginning, whose future value is what I'm given, whose future value, and then if you look at number 35, it's 55,000. Monthly payments, so payments are monthly, so this is going to be 12 times the number of years, which also was 12 years. So this is 12 times 12. At an interest rate of 5.7%, and compounding will match payments when we have payments. Present value I wasn't given, but I don't need it. Any questions on that? So then when we enter it, I highlighted, this one had the 0. Then I hit alpha and enter, and there's my answer. $265.71. Any questions on that? I wouldn't take off if you put a negative sign, but technically it shouldn't be there. But I would not take off. My math lab would probably take off if you put a negative, because technically it's not correct. So my math lab would take off for it, but on a test, I wouldn't take off. Any questions on that one? $37. This one here. It goes on to the other side, so I'll have to move it over. So it says a typical pack-a-day smoker in Ohio spends $170 per month on cigarettes. Suppose the smoker invests that amount at the end of each month in an investment fund that pays a return. So just from this part here, it said we were going to make monthly payments. So instead of buying the cigarettes, we were going to put that money into an account at the end of each cycle every month. Any questions on that part? At a rate of 5.3%, compounded monthly, what would the account be worth after 40 years? So if we want to know how much it's worth after 40 years, are we looking for a present value or a future value? Anyone? Yes. We're looking for future value. So this is where we're going to put our cursor. We don't know present value either, but this is the one we're looking for. We'll use this more. I believe the next section is loans. And so then when you get a loan, it's present value. What is N? Yes. 40 years, payments are monthly, 40 times 12. So we're looking for future value. 40 times 12, 5.3. Now remember to switch it to the end and then go to future value with your cursor. Alpha, enter. Getting 280 some thousand. And so if you put $170 a month away at 5.3% in 40 years, you'll have $280,000. Any questions on that? Positive. Next one I want to look at was 44 because it's a confusing one. I definitely wouldn't put it on an exam. Because there's a couple different things. Well, go ahead and read it and see where you would put things and what you would put. A grandmother opens an investment account for her only granddaughter on the day she's born, investing $500. Each year on her birthday, she deposits another $500. So she's making payments of $500. That I think we're in agreement with. Making the last deposit on her 25th birthday. So what's N? 25. Now we know she's making these yearly, so we know that's going to be a 1. And if this is compounded year, payments are yearly, compounding has to be yearly. I think it's 26. The reason being, and if I put this on a test, I would have accepted both. But at first I put 25, but then I thought about it. If she's putting it the day she's born, and then she puts another one the second day, that's actually two payments. Her first birthday, sorry. So on her first birthday, she's already made two payments. So I should have checked, seen if they had this answer in the back of the book. I didn't look. But I think it's 26 because the day she's born, she puts it in. The next year, which is only the first year, she's going to have two payments now, which means two cycles. So it should be, I think, 26. Everyone agree with that? Okay. And it's 26 times 1 because this is a 1. Did they give us 44? Interest rate was 6.2. We don't have a present value, and we're looking for a future value. Now, the other thing, it doesn't say it's annuity due, but it does say how much is in the account at the end of the day on the granddaughter's birthday. So it doesn't really say if she's putting them in at the beginning or the end. When it doesn't say annuity due or payments at the beginning, I would use end. We're going to do both so that you could see what the difference looks like. But any questions on these values? And this is the one we want to put our cursor at. Okay. So we go up to future value, alpha and enter. You're getting $30,466.97. Is that what everyone got? 6.2. Yeah. Now let's do the same problem, but make the payments at the beginning. So everything's going to be the same except at the very bottom, you'll put beginning. Then we'll go to future value. Make sure you make it a 0 again. You should get $32,355.92. So notice it's over almost $2,000 difference. The reason it's different, if you put money into an account at the beginning of the, say it's monthly, at the or this one's yearly. At the beginning of the year, you're making interest off of it. If you put it at the end, you're not making interest off of it that year. So when it's compounding, if you put it in at the beginning of a cycle, you make interest off of it. So this $500 at the beginning of the year, she made 6.2 interest on it that year. If she put it at the end, then that first year she wouldn't make interest on it. And so by putting it in at the beginning, you're making more interest. Any questions on that? Positive. One more. Let's try number 48. This one here. Okay, so go ahead and try that one. What number? Oh, sorry, number 48. The one I highlighted. Does anyone want to say what they got? 1349. Yep, that's what I got. It says, Harv's Meats knows that it must buy a new machine in 4 years. The machine costs $12,000, so in the future I need $12,000. In order to accumulate enough money to pay for the machine, Harv decides to deposit a sum of money, so that's what we're looking for, to pay for the machine. He decides sum of money at the end of each 6 months. So if he's doing it at the end of each 6 month period, that means he's making payments twice in a year. In an account paying 6% compounded semi-annually, both two, how much should each payment be? Any questions on that? So then when you hit alpha and enter, you get $1,349.48. Any questions? Make sure you try these on my math lab, because when I'm doing them here, it looks completely different than when you go home and do it yourself. So if you have any questions or you're not sure what you're typing in, just send me a picture of your problem and this, so then I know what you're trying to type in and we can find your mistakes before the test. If you have any questions, let me know. Time went fast.